give notifications of all. Okay, make sure we're recording and you may begin when ready.
All right, good morning, everybody. Our team is Group 1, and today we're presenting our Progress Report 1 for our AGSM 440 capstone project. Our project title is Integrated Dust Management System. Dust might seem like a minor issue at first, but in livestock operation, it can significantly impact animal respiratory health, worker safety, and even day-to-day operation efficiency. Thank you, sir. Anyways, because of this, our team is focusing on developing a solution that addresses dust in a more consistent, efficient, and a sustainable way. This presentation serves as an overview of our project direction so far, including the problem we're solving, the constraints we face, and how we plan to move forward. This slide shows the agenda for today's presentation. We'll begin by giving a project description and an overview, which explains the scope of our work and what we plan to accomplish. Next, we'll discuss the constraints influencing our design, such as water availability, budget considerations, and ranch operating conditions. We'll also go over our planned deliverables, review relevant literature and existing dust control methods, and briefly touch on similar solutions that are currently used in a comparable setting. Finally, we'll look at our project timeline shown through a Gantt chart and outline our next steps as we move toward the next progress report. Our project focuses on the design of a semi to fully automated water-based dust control system for livestock operation. This is known as an integrated dust management system. The system is being developed specifically for Two Rivers Management Company in Sabinal, Texas. They experience hot temperatures, limited rainfall, and persistent dust problems. These environmental conditions make dust control both critical and challenging. The IDMS is intended to target high traffic areas such as cattle pens, grow yards, alleyways, and ranch roads. These are areas that consistently produce high levels of dust concentrations due to constant activity. A major priority of our design is water efficiency. Since water availability is limited in South Texas and current dust mitigation methods tend to use excessive amounts of water, another key focus is automation, which would reduce the need for manual spraying and labor-intensive water truck operations, while also improving consistency in dust suppression. Overall, our goal is to develop a system that is reliable, practical, and adaptable to the changing environment that is West Texas.
So our project overview has a project scope, key deliverables, and expected outcomes. So for our project scope, we're evaluating how much dust is actually in the air, so make sure that we evaluate how much dust we're moving from the air. We actually have a measure for that. We're also going to use a water-based system for our project. Some of the key deliverables are that we have a IDSM technical report with the alternative comparisons, so other solutions that are recommended solutions that we may come up with, and of course now the economic analysis, and then finally an implementation plan for that solution. Our expected outcome is to have something cost-effective, reliable, easily maintainable, and then also automated so that we're semi-autonomous, so that it doesn't involve too much labor. So our constraints obviously are water limitations, how much water we can use in that area, and how much water we can get there. Another thing is our ranch operating conditions. It's going to be very dry. There's not a lot of personnel to maintain the roadways and ends to make sure that dust is down. So that's kind of the reason why we're introducing an automated system. And of course, the budget and the scalability of that project needs to be within reason of So some of our deliverables here, so we're gonna have background research done, which most of that right now, potential solutions that we're working on, and some recommended solutions that we'll do analysis on, make sure that it's something good with the client, and then cost benefit analysis, risk analysis, implementation plan, and then finally, of course, the presentation.
So our literature review will be our next paper, basically, which is going to be our second formal report, which will be produced here in the next few weeks. It's going to be about our dust in livestock operations and basically how that affects, how dust affects cattle, as well as worker health, as well as the safety of workers that are operating on and around the work site as they're driving along. Dust being pushed up in the air could cause collisions between workers and cattle, workers and other workers driving or even walking. So we kind of expanded in our paper about the existing dust control methods that they have there. Basically, they're using manual spraying and a spray truck, a water truck, to drive around the property. And that's kind of used high amounts of water as well as excessive labor. So just to kind of go through and to explain to our client what we know that he has given us, and to kind of explain from there the inconsistencies and ineffectiveness of what is already there. Then we'll be moving forward and expanding on some key findings that we found in our literature, which is going to be kind of our targeted water and autonomy, and how we can get a better efficiency of getting actual dust detection, as well as how we can reduce labor. So our similar solutions that we've looked into is some truck spraying that is used in construction, as well as diluted chemical sprays. So some chemical sprays that are used are calcium chloride and magnesium chloride. Basically, this is mixed into the water and sprayed, and having those particles in the water increases prolonged mitigation of dust. And then some other things we've looked into are some current autonomous systems, which would include GIS, GPS, and LiDAR. They are automated machine spraying, which has been used for row crops, as well as some dust mitigation as well. And then another thing that we've kind of found is that fixed irrigation spraying, which would be pretty similar to setting up spots along roadsides or other locations where it might be dust heavy, and how we can use like an automated mist cannon, which has been used, and then IoT and AI dust monitoring, basically just using computer AI to pick up areas that are high concentration. Potential resources that we've looked into would include simulations using the WEPS, which is the Wind Erosion Protection System, and looking into how they've used their system and how we could potentially incorporate that into ours, as well as historic soil composition data for that area, and being able to kind of get an idea of what we're going to be dealing with. Some water management software, the SCADA systems, or simple IoT controllers for sensor data. Discuss methods with our faculty advisor and kind of get her input with things, as well as look into the EPA regulations, which is the Environmental Protection Agency. They have an index of regulations for dust mitigation and management.
So we created a project timeline just so it allows us as a team, our faculty advisor, as well as our client, to have an understanding of what is going down throughout the semester. Of course, we're starting from today all the way to the end of April. As of now, as of currently, I should say, we're currently working on homework 2, which is the initial draft. That is due this Thursday. We're still working on it. It's not really due until February 17th. And because of this, we have other overlays as well, such as homework 3. We'll be beginning to work on it starting next week, as well as homework 4 following along. Additionally, you'll be able to see that there's faculty advisory meetings. This allows us to talk to our advisor to gain any feedback on our work, as well as gain some information as well. And then lastly, we have our poster session, our capstone poster session. During this, we'll start getting with finishing up our poster presentation and final reports. Again, this project Gantt chart is to help us, our team, advisor, and our client to understand what needs to be done throughout the semester. To wrap things up here, I'll discuss what is going to happen in the 2 weeks before our next progress report. We'll continue our background research on the following: the health and economic impacts of dust on cattle, as well as the figuring out the suppression technologies used for the ranch, and as well as understanding the Two Rivers Ranch water and electrical infrastructure. Additionally, with the ranch infrastructure, we'll begin doing a planned site. So we'll go talk with Mr. Ochoa and figuring out an appropriate date to see when he's available for all of us to see. Additionally, we'll also plan a faculty advisory meeting with our advisor before February 3rd to figure out any information we need to finalize our homework 2. And our next progress report will be on February 3rd, as of right now. And that is the end of our progress report. We're open to any questions, thoughts, or concerns.
Okay, why don't we start with over here with Dr. King, any comment or question?
Thank you for the presentations. It's very interesting. So it's quite far. So I may have missed it, but I can give a question. So, for example, what is the area that is to be? Is it mostly the road or 3 blocks or?
It's mainly the feedlots, but of course, dust from the roads can accumulate to that area, but we're mainly focusing on like the cattle area.
So what is the size
Questions answered, and hopefully be able to go out to the site and see it for ourselves.
it's like acres?
I believe so.
How far is this place?
About 5 hours away, west of San Antonio.
So now when you are speaking, so that really is a very delicate process because you can easily suspend more dust and then you just stay high and of course the evaporation will take over the greater dust affect the soil. So also think that the people tend to know what's the size of this park because we spend a lot of cleaning in that area. So to basically ask these questions from the locals or look up the desert report for that area needs, you can go back to the desert and then an idea of what the places are. And now when you show that calcium chloride, magnesium chloride in the spray, so is it okay? That's a lot of salt. Is it allowed to use for the soil?
It would be like in small amounts. For the soil, we would have to do some more research on the effects of the actual soil and how that would affect them, as well as potential overspray and how that could affect the cattle or even workers. So it would be something that we would just continue to look into.
You can basically look for other things, not just water, so also other solutions regarding the, because there is when we worked for, we had a nuclear engineering project, and basically we had to test that. So after 4 hours, when they spray everything, it shouldn't be suspended. So they came up with a fire retardant, which is an organic phosphate material. We still have a lot of that. So if you want to test, like for example, that tool, it's really it's a great material because it makes everything kind of stay down. Okay. So that's another, because at places like this, I mean, if you keep spraying and then coming up with a great nozzle design that will keep your water really close to the soil, I think that's so. I like to try everything possible. forward to the meeting and then maybe have more information, so I just go through those and see how they fit into the project.
Okay. Why don't you go ahead and